use the discriminant to determine the number and type of solution. If a, b, and c are integers in a quadratic equation, ax squared plus bx plus c equal to 0, then discriminant would be b squared minus 4ac. If you remember the formula, we had x is equal to minus b plus and minus square root of something over 2a. That would be b squared minus 4ac. So what we have under the radical would help us to see what type of solution we get. That's what they call it, discriminant. Just stuff under the radical. The terms under the radical is b squared minus 4ac. Would help us to find out what type of solution we get. Okay, if b squared minus 4ac, discriminant, is positive and square of an integer, if this number come out to be called positive, like 4, and also the square root of some number, 4 is a good example. So if that would be minus b plus or minus square root of 4 over 2a. So if this is positive and square of some number like 4, then the answer would be minus b plus and minus square root of 4 over 2a, or minus minus square root of 4 over 2a. So square root of 4 would be equal to 2. So we get, as a result, 2 rational numbers. So if the number under the radical is positive and the square of some number, we get 2 rational numbers. That makes sense. Now, however, if the discriminant is positive but not the square of an integer, like it would be 2, if this is square root of 2, then we get 2 solutions. But the answer would be rational. We have that square root of 2 in there, which is a rational number. Remember, the square of prime numbers are irrational, like square root of 2, square root of 5. So you have to see whether it would be the square of integer. If it is like 4, that would be 2 rational number. Otherwise, it would be 2 irrational numbers. Now, if it's 0, if b squared minus 4 is equal to 0, so this term would be all gone, then we get like 2 identical solutions, minus b plus and minus 0 over 2a. Both would be the same. So actually, we get 1 rational numbers. In reality, we get 2 identical solutions there. Now, the last case would be where b squared minus 4ac would be negative. We looked at some example of this already. If this turns out to be negative, then we get 2 non-real complex numbers. Then we get those i's appears in our solutions. Like we had, like our minus 4 here, then would be minus 1 times radical 4, which is equal to 2i. We looked at some example already on that. So by looking at the discriminant, by looking at the value of b squared minus 4ac, we can find whether we have 2 rational solutions, or 2 irrational solutions, or 1 rational solution, or 2 non-real complex solutions. Find the discriminant, use it to predict the number and type of solution for each equation. Tell whether the equation can be solved by factoring or whether the quadratic formula should be used. Well, here this is an example. 10x squared minus x minus 2. Well, we have to figure out what is b squared minus 4ac is. That's what the discriminant, that's what we have under the radical in our quadratic formula. Again, recall x is equal to minus b plus and minus square root of this. The terms b squared minus 4ac under the radical would help us to see what type of solution we have. B squared minus 4ac. Okay, we find that by locating a, b, and c's. A is obviously 10, that's the coefficient of x squared. B is minus 1, that's the coefficient of x, and the constant is minus 2. That's all I have to do, just substitute those values into this formula. B squared minus 4ac, that would be minus 1 squared minus 4. My a is 10, my c is minus 2, so minus 1 squared would be 1. So I multiply these 3 numbers together, negative 4 times 10 times negative 2 give me 80. So here it is, 81. B squared minus 4ac would be 81, is a positive number, and also perfect square. So let's take a look at my chart. We said if it's positive and square, we get two rational solutions for that. And the equation can be solved by factoring. When we get two rational solutions, we can easily factor this. Use the discriminate, use it to predict the number and type of solutions for each equation. Tell whether the equation can be solved by factoring or whether the quadratic formula should be used. Quadratic formula. Remember quadratic formula? Let's write it down here. X is equal to minus b plus and minus square root of something. What is that? Over 2a. What do we have under the radical? B squared minus what? 4ac. So this is what is called discriminate. So here we need to find that by locating the values of a, b, and c. So in this case, I need to write this in standard form by adding minus 7 to both sides of the equation here. I get 3x squared minus x minus 7 equal to 0, standard form. My a is 3, b is minus 1, constant is negative 7. Substituting those values into b squared minus 4ac, I get minus 1 squared, which is equal to 1. Minus 4, my a is 3, my c is negative 7. The product of these three terms would be negative 4 times 3 times negative 7 would be equal to 84. Looks like my answer would be 85. 85. So there will be two irrational solutions. Why irrational solution? Remember the chart? If I go back to that chart, if I can find my chart quickly, there it is. See, if what I have under the radical, b squared minus 4ac, is positive, it is positive, but it's not square of an integer, so that would be two irrational solutions. So this would be like 2, 5, 11, or in this case, 85. There would be two irrational solution. So solve using the quadratic formula. So we don't want to factor this. We cannot factor this really. So we need to use the quadratic formula to solve for this. Find the discriminate, use it to predict the number and type of solutions for each equation. Tell whether the equation can be solved by factoring or whether the quadratic formula should be used. So here we have our example. We need to write this in the standard form. If I subtract 40x, what's of the equation? I can write it as its standard form, 16x squared minus 40x plus 25 equal to 0. Now I need to identify the values of a, b, and c. Once again, the quadratic formula is minus b plus and minus square root of something over 2a. That would be b squared minus 4ac. This is the discriminant that we're talking about. If I find the value of this, then I would know what type of solution I have. In this case, my b is minus 40. That would be minus 40 squared, which is 1600. Minus 4ac, my a is 16, c is 25. If I multiply minus 4 times 16 times 25, I get 1600. Here I get 0. So when I get 0 here, means there will be one rational solution and the equation can be solved by factoring. Here again is a chart. If it's 0, if the discriminant is equal to 0, then we get one rational solution. Find the discriminant, use it to predict the number and type of solutions for each equation. Tell whether the equation can be solved by factoring or whether the quadratic formula should be used. Here we have our example, 10x squared minus x plus 2 is equal to 0. Once again, quadratic formula would look like minus b plus and minus square root of b squared minus 4ac divided by 2a. All the terms under the radical is our discriminant. So in this case, we find the values of a, b, and c. A is 10, b is minus 1, C is 2. So B squared would be minus 1, which is equal to just 1. Minus 4AC, A is 10, C is 2, so it would be minus 4 times 10 times 2. It would be 80. You notice that the discriminant would be negative 79. So when the number under the radical is negative, then we conclude that we get two non-real or complex numbers. This is where we have i's appears in our solution.